Hello, bachas. Welcome back to the channel The F in Physics, where the F in Physics stands for fun. So today we are solving a paper. It's 24, paper 2, variant 1. Let's go. So I want you all to sit with a book and make down note down everything that you feel is important in the video. Let's begin. Now, in which row are quantities correctly categorized into scalar quantities, which means they should only have magnitude, and vector quantities, which means magnitude along with direction? Let's see the options. Mass, I know, is scalar. Energy and work, a lot of you feel it is vector, but no, it is scalar. Weight is vector. Acceleration is also vector, which means A looks perfect. We are lucky enough to get the answer as A. Let's look at the other options. Gravitational field strength is vector. That's why B cannot be the answer. Just cross checking. Distance is scalar, cannot be the answer. And for Delhi, temperature is also scalar, which means the only correct answer over here is A. The next question. Which name is given to the quantity of matter? Amount of matter. We know amount of matter is mass, because density is this amount of matter divided by volume. Volume is the space occupied, and weight is the gravitational force acting on matter, which means answer 2 is Bombay. The third one. A body is moved from place X to place Y, where the gravitational field strength is different. So there is a change in G. Correct? What happens to the mass? I know my mass, which is the amount of matter. No matter where you go, amount of matter won't escape. It won't come into your body. So my mass remains the same. But my weight is the gravitational force acting. And force depends upon field. So if your field is changing, your weight is going to change, which means this is changing. And the correct answer showing that mass is same but the weight is changing is C. Okay, we go on to the fourth one. Straightforward question. Mass is 2500, volume is 480 centimeter cube, density is mass upon volume. But if you look at the options, mass is in grams, so convert this. Kilo means 1000, so 2500 upon 480. Round this up to 50, and this becomes 5. The closest answer is Bombay. I don't have a calculator, so I'm just rounding it up. You people can use a calculator. Fifth one. 4 objects, each having 2 forces, are acting on them. You can see in the diagram. Which object is in equilibrium? Remember, whenever they say which object is in equilibrium, which means there is no net force and no net moment, which means no turning effect and no resultant force. If you look at option A, they're acting along the same line and in opposite direction, which means both the conditions are satisfied. But if you look at Bombay, yes, the values are same. It may look like the answer, but this will produce rotation. For such questions, keep an object in front of you. Keep your compass box and apply forces and see where this is satisfied. Okay, you will see that the answer turns out to be an option where the forces are acting in line. If there are 2 forces, mind it. The sixth one. A ball of mass m, this is my mass given, falls vertically and hits the surface. The speed by which it hits the surface is v1. Okay, which means this is my initial velocity. It rebounds vertically upwards, which means there is a change in direction. Okay, with the speed v2. See, they have mentioned the word speed. Very smart these people are. They want you to find change in momentum. Make a note of this. This is an FAQ. Whenever objects bounce back, change in momentum, which is normally given as mv minus mu, becomes mv plus mu, because momentum depends on velocity. If your velocity reverses, the sign will get flipped. Okay, so if my v is plus v2, my u is written as minus v1. Why minus v1? Because it is bouncing back, or it is moving in the other direction. I'm so sorry. Which means your change in momentum will be m times v, which is plus v2, minus of minus V1, which turns out to be option C. You get the same answer if you reverse the sign. You will get m times minus V2 minus V1. See, again you are adding the velocities. We clear? Chalo, let's move on to the 7th question. A stone is dropped from a tall tower and it falls a distance 50 meter to the ground. So if this is my tower, this is the stone, this is the height 50 meter from the center of mass. 50 meter, perfect. The mass is 3 kg. At what speed does the stone hit the ground? We know at this height the stone has mgh. Just before hitting the ground, all its GPE gets converted to KE, which means my mgh gets converted to half mv square. You can get rid of the mass, you get velocities under root of 2gh. So under root of 2g, I don't have a calculator, 10, height is 50. Just remember, you cannot take this value as 10, you have to take it as 9.8. This comes out to be 100,000. Under root of 1000, which cannot be 17, it has to be Bombay then. This is close to 1000. You kids please use a calculator and use this value as 9.8. The 8th one, a coal-fired power station. Remember, you're using coal as the fuel. Any fuel has chemical energy, which means coal will have chemical energy. Okay, so coal power fire station is used to generate electricity. Coal is burnt and the energy release is used to boil water. Another MCQ that they can ask you is, which of these power stations produce energy by boiling water? Okay, very common question, 2015 to 2017, you can check. Now, the steam from the water makes the generator move and this produces electricity. This is what you kids have studied in magnetism, that there is a coil which is rotating. Which row gives the name of the energy stored in the coal? Like we said, energy in the coal has to be chemical. And the energy stored in moving generator, anything that's moving will have kinetic energy. So the answer becomes Bombay. The 9th one, a man puts some ice into a glass of water on a warm day. After a short time, he notices that the ice disappears, okay, which means ice is melting and water droplets are formed, which means the gases outside is absorbing the energy and turning into liquid. Okay, ice melting, so melting, and the gas turning into liquid, which cannot be boiling obviously. Okay, neither it is freezing because my ice is melting, so you are only left with Bombay, condensation. 10th one, the moment you see piston, you need to know that this is a Boyle's law question. P1 V1 equals P2 V2. Okay, chalo, let's read the question. A gas of volume 200 centimeter cube, so I'm pretty sure this is going to be my V1. Okay, is trapped inside a container by a piston. You can see the piston. The piston is pushed to the right. Let's assume the new position of the piston is here. So you have reduced your volume. And they're telling you that the volume is decreased to 100. Which means from initial volume of 200, it is now becoming 100. So your volume has halved. Which means your pressure will double. Correct? Because P1 V1 has to be equal to P2 V2. The temperature of the gas remains constant. This is another keyword used whenever they want you to use Boyle's law, that the temperature remains constant. Now, which row states the effect that this has on the kinetic energy? Kinetic energy is half mv square, which is dependent on velocity, and my velocity is dependent on temperature. So if your temperature is constant, your kinetic energy has to remain constant, which means the answer is either C or D. Now, force per unit area is pressure. We saw that the pressure is doubling, which means the answer has to be C. Okay, 11th one. Which graph shows the relationship between pressure and volume for a fixed mass of a gas? Remember, for Boyle's law, not just temperature, but also mass remains constant. Okay, and that is what this statement over here means, which means they're talking about pressure is inversely proportional to volume. And whenever two quantities are inversely proportional, the graph is going to be of this shape. It can never be like this because inverse relations do not obey the equation y is equal to mx. Okay, so the answer is Delhi. 12th one. During evaporation of a liquid, the most energetic particles escape. We know this. The temperature of the remaining liquid changes. We know that evaporation produces cooling effect because high energetic particles have escaped, which means low energy particles are left, which means your temperature is less, which means your speed is less. Correct? Now let's read the further part of the question. Which row identifies where these particles escape from and describe the temperature change? Now evaporation is the surface phenomena, which means the molecules are escaping from the surface. So the answer has to be either C or D. And because most energetic particles have left, you are only left with particles with low energy, which means low temperature. So your temperature is decreasing. So surface and decreases, which means C. 13th one. Wet clothes are put on a line to allow water into the clothes evaporate. Areva, one more evaporation question. Which type of weather would cause the evaporation to happen more quickly? Now, bio students, evaporation is very similar to transpiration. So cold day will not produce as much evaporation as a hot day. So the answer is either C or D. And of course, when there is wind, there is more evaporation, and hence your answer has to be Delhi, D. 14th, there's no question. Okay. 15th, a solar water heater is designed to absorb energy. Absorb. Okay, good absorbers. Which surface texture and color would be the best for this solar heater? Okay, we know anything that is black and has a rough surface is going to be a good absorber. So anything that is shiny is out and anything that is not black is out. So you're left with A. 16th, which statement about a wave is correct? Wave. Okay, waves do not transfer either energy or matter. Now this is why I tell you all to read the syllabus. Everything is mentioned in the syllabus. Okay, so whenever you talk about progressive waves, which is in your syllabus, they transfer energy. Matter does not move, which means matter only vibrates, and therefore in longitudinal and transverse you stick to the word vibration. Okay, which means A is wrong. Waves transfer both energy and matter. Lol. B is also wrong. Waves transfer energy without transferring matter. C looks good. Waves transfer matter. No. So the answer is C. 17th. Okay, from here my calculations begin, I guess. Chalo, the angle of incidence of a ray of light incident on a plane mirror is gradually increased. Fair enough. To the nearest degree, which is the maximum possible angle between the incident ray and the reflected ray. Okay, 180. So if this is my mirror, and let's assume here is the light. If I incident straight, it's going to reflect back. Kids will think that's 180 degree, but that's wrong. Over here, your angle of incidence is 0 degree. Now, if I keep increasing this, okay, I can go beyond this. Let's look at the next angle, 45 degree. 45 degree is somewhere over here. I still have a lot of room, correct? So I can increase this. I know my angle of incidence and my angle of reflection is the same. So if I go to 89 degree, my reflection also is 89 degree. Are you understanding this? Which means the maximum possible angle could be 89 plus 89 and more than that. So 180. I cannot go beyond this. We clear? Now, to be very frank, it is also not 180. It's less than 180. Okay? But yes, I can assume it to be 180 because all the other options are wrong. Now, the 8th one. Which conditions are necessary for light to be totally internally reflected? Now for TIR to take place, two things are needed. First, the ray should travel from a more dense medium into a less dense medium. Only then your angle of refraction will be greater than angle of incidence. Okay, so it has to be more dense to less dense, which means it's either C or D. And the angle of incidence, my angle of incidence has to be greater than critical angle, because if it is less, I only have internal reflection and not total internal reflection. So my correct answer has to be Delhi for this one, D. 19th, I can see there's angle of incidence, there is angle of reflection, both with the normal. Perfect. Refractive index will be sine 40 upon sine 30. Okay, I don't have a calculator. Please go ahead and do this yourself. 20th one, this is a good question. Now, the diagram shows a ray of light in an optical fiber. Which statement correctly explains the condition for maximum transmission by optical fiber? How does a light gets transmitted from point A to point B? Via total internal reflection. And we just saw that for TIR to take place, your angle of incidence has to be greater than critical angle. Okay, now this critical angle is exactly like your grade threshold. If your grade threshold is higher, less chances for students to clear the exam. But if your grade threshold is lower, more chances of students to secure an A star, right? Okay, which means for more TIR to take place, my grade threshold, which is my critical angle, has to be less. So let's look at the options. Critical angle to be less as possible. It's either Bombay or Delhi. A and C are out, because if your critical angle is large, your angle of incidence has to be larger and the possibility reduces. Okay, so now I know that my critical angle, not refractive index, my critical angle is small. I also know that my critical angle is inversely proportional to refractive index. Correct? Because refractive index is 1 upon sine C. So if your critical angle is smaller, it means your refractive index has to be larger. And your refractive index is speed of light in air upon speed of light in medium. So if your refractive index is larger, your speed in medium has to be smaller. So the correct answer is Delhi. That is why I told you this is a very good question. Whenever you have questions like this, I want you all to write the formulas. Only and only then you will be able to solve such questions. Okay, moving on to the 21st one. Which region of the electromagnetic spectrum is used for detecting fake bank notes? This is again mentioned in the syllabus. I want you all to read this unit strictly from the syllabus. Okay, and the answer has to be ultraviolet. Moving on to the 22nd one. Sound wave travels at this speed. The distance between the center of a compression and the center of the nearest rarefaction is 2.5 centimeter. Now I personally find compressions, rarefactions slightly confusing, but I do know compression is a region of high pressure. So your pressure is high and over here your pressure is low. And I also know that sound waves are basically pressure waves, where this is your high pressure, this is your lower pressure. Okay, so your waves are something like this. The highest pressure is compression and the lowest pressure is rarefaction, and this is what they have given. So you can assume this to be the crest. So from crest to trough, which is half the wave. So half the wave is 2.5. So your complete wave becomes 5 centimeter. Now use V equals F lambda and get the answer. Just remember, speed is in meter. Your wavelength needs to be converted to meters. Be clear with this? Yes, you can also do it by compression rarefaction method. Wavelength is the distance between center of one compression to the center of the next compression, which means they have given me half the wavelength. Okay, but I personally prefer this sound waves as pressure waves. 23rd one. Which waves are used in scanning of soft tissues? It is soft tissues, so the wave needs to have less energy. 23rd. And now you know the answer for this one. Again, like I told you, I want you to do this unit strictly from the syllabus as everything is mentioned over there. Okay. 24th. Which row describes suitable material for temporary magnets and permanent magnets? Temporary magnets, we know soft iron is a temporary magnet because my domains align and they de-align quickly. So for temporary magnets, I will use soft iron. And if I'm using soft iron for temporary magnets, I obviously cannot use soft iron for permanent magnets because they are hard magnets. And therefore, the answer has to be Bombay. 25th. A magnetic field is represented in the diagram. Perfect. You can see the magnetic field lines. At what point is the field strongest? The field is going to be strongest where the separation is the least, or where the distance between the field lines is the least. And you can see with your naked eyes that the answer is going to be A. Now 26th. A student determines the resistance of resistor R. If you're determining the resistance of resistor R, you use Ohm's law, which means you need voltage across it and you need the current flowing through it. Okay. She uses a circuit involving voltmeter and ammeter, very obvious. Now voltmeters are always connected in parallel, ammeters are connected in series. Okay. Now, so voltmeter, parallel, ammeter, series, there is only one circuit that gives me the answer. Be clear? This is wrong. Ammeter cannot be connected in parallel. All the current will flow through this ammeter. Actually, no current will flow because of this voltmeter. Okay, this is shorting the circuit, and this is also wrong. 27. This is one question where a lot of you kids have a confusion. Chalo. So a diode and a resistor are connected across a variable DC supply source. Perfect. Terminal X is positive charge and positive and at maximum value, which means terminal Y is negatively charged. Okay. The PD is adjusted, blah, 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 blah. Which graph shows how the current in the circuit varies during the same time interval? Now what they have mentioned is terminal X is initially positive. So this is my positive and this is my negative. And you can see that your voltage initially is turning to 0. It's decreasing. Now when X is positive, Y is negative. Look at how my conventional current flows. If you have seen my video on diode, this is in a reverse bias connection. And whenever a diode is in a reverse bias connection, it won't work, which means for this part of the graph, my current has to be 0. And there is only one graph which tells me my initial current is 0, and that is Delhi. Then sir, why is current flowing here? Understand this, when the PD across XY becomes negative, it means now your Y has got a positive charge and this becomes a lower potential. Y has become a higher potential, which means you have connected the voltmeters ulta. Now if this is positive, my current flows through the diode, this is my forward bias connection and my circuit is complete. Okay, so even if you cannot figure out what's happening here, you can actually make out the answer just by looking at this. Okay, it's this line over here is my keyword. Terminal X is positive. So when initially your terminal X is positive, this is negative, reverse bias, current should not flow. So that is why the answer has to be Delhi. 28th. When a conductor in a complete circuit cuts a magnetic field, Faraday's law, a current is induced. Which statement about the induced current is correct? Wow, let's look at the options. The induced current is in the same direction as the motion. Ouch. As per Lenz's law, this cannot be the answer. The induced current is in the opposite direction as that of the motion. Now, as per Lenz's law, even this cannot be the answer because your current is perpendicular to magnetic field. Okay, the direction of induced current is in the same direction. Like we said, these three are wrong because your current has to be perpendicular to magnetic field. That is how you use your left and your right hand rule, right? Whenever you use your left or the right hand rule, if you look, your magnetic field and your current always have to be perpendicular, which means A, B, C are wrong. So you are only left with option Delhi. And this is what your Lenz's law talks about. Actually, I'm sorry, this should be Faraday's law. Okay, and Fleming's left hand rule. So A, B, C are out. 28th, the diagram shows a solenoid carrying electric current, solenoid carrying electric current. Okay, so this is an electromagnet. Which row compares the strength of magnetic field due to the solenoid at points Y and Z? Okay, chalo. So you know to find the magnetic field, the strength of magnetic field, that is given by the spacing between the magnetic field lines. You'll remember a similar question was asked here. Okay, and let's assume there are only two field lines, one at the top, one at the bottom. So this is the top one, this is the bottom one. This is how the field lines would be. So my field lines are, obviously they have to be parallel at the center because my field lines are repelling each other, something like this. Now look where the field lines are close, because in between the coil my field lines are parallel. X and Y have the same strength, same force will be exerted at these points. Okay, so X and Y has to be the same, and Z, the spacing is large, which means the force has to be smaller. So A. This is why they say that the magnetic field strength is strongest at the poles, and minded your poles are not exactly at the ends, they are somewhere in the magnet, 5/6 the length of the magnet. Okay, the 30th question. A conducting wire is placed between the poles of a magnet. Perfect, I have a conducting wire in between the poles. When there is an electric current in the wire, there is a force, and the force is out of the page. So whenever there is a current in the downward direction, this is your page, this is the left of the page, right of the page, up of the page, down the page, which means if it is coming out of your screen, that's out the page. If it is going into the screen, that's into the page. Okay, in this case what they are telling us, when the magnetic field is from left to right and your current is down your screen, then this wire should pop out of the screen. That is what this line tells you. Now, three statements are given. When the current is towards the top, so you are reversing the direction of current, and the direction of magnetic field is unchanged, the force is acting into the page. So what this line tells you is, if current reversed, if the direction of current is reversed, the direction of force reverses, which is correct. If you use your left hand rule, if you keep your direction of magnetic field same, but if you reverse the direction of current, your thumb will point in the opposite direction. Second one, when the direction of current is towards the bottom of the page, which means now the direction of current is the same, but now you're reversing magnetic field. Okay, force is acting into the page, which means if you keep your current same, but if you reverse the magnetic field, the direction of force will change. Okay, even this sounds correct. Now, so even this is correct. When the current in the wire is alternating, which means the direction is reversing, nothing is written about the magnetic field, which means my magnetic field is the same. The wires vibrate, vibrates in and out of the page. If you look, 1 and 3 support each other. So if 1 is correct, 3 has to be correct. Are you understanding this? which means the answer is either C or A. And I know 2 is also correct, which means the answer has to be A. We clear with this? If you change any one direction, the direction of force will change. My question to you all is, drop it down in the comment section. What if I change both the direction of current and the direction of magnetic field? Will my direction of force change? Think. Chalo, 31st. Which type of electric current is used in primary coil and secondary coil of a step-down transformer? See, transformers work on AC and they produce AC, which means the answer over here straightforward is going to be AC. Okay. 32. A scientist fires alpha particles at a thin gold sheet and detects the particles that pass through. Which statement about the results is correct? So it's basically alpha scattering experiment. Let's read the options. Alpha particles are attracted to the nucleus. Alpha particles are positive charge, nucleus positive charge. Lol, positive cannot attract. Half the mass of atom is concentrated in the nucleus, which means other half is in the electrons. Ouch, wrong. Most of the alpha particles are deflected. Even this is wrong. If most of the alpha particles are deflected, it means that what do you say, the atom, okay, is not hollow. So even this is wrong. Only a small number of alpha particles are deflected, but some of them are deflected through large angle, and this makes sense. Small alpha particles deflected, telling you that it is hollow, and large angle tells you that the entire mass is concentrated in the nucleus. Okay. 33. The notation represents the nucleus of gold atom. The relative charge is +1. What is the charge on a proton, is +1. What is the relative charge on the gold nucleus? If one proton has a relative charge of +1, then 79 protons will have a relative charge of. Do the calculations yourself, not solving this one. 34th. An isotope of hydrogen has this notation. Fair enough. How many neutrons are there in the nucleus of this isotope? And what is the relative charge? Again, the same thing. You have to use this. So it has one proton. So your relative charge is going to be 1, which means the answer is either A or it is C. And neutrons. Neutron is your mass number minus the proton number, which gives you option A as the correct answer. 35th. A radioactive source is placed near the detector. You can look at the diagram. This is my source. This is my detector. Perfect. The radiations arriving at the detector from the source is measured for 10 minutes. Okay. With different materials placed in between. Fair enough. So when there is nothing, this is my count rate. With a thin sheet of paper, my count rate is not changing, which means it is not alpha. Correct? With thin sheet of aluminium, my count is reducing by half. And with a thick sheet of lead, my count decreases significantly. Are you understanding? With thin sheet of aluminium, it reduced by half. If it was only gamma, then this count should not change. But it reduced, which means there is beta present. And with lead, your count decreased by a large amount, which means there is gamma. So your answer has to be C. Beta and gamma. Anything with alpha is out. With beta is also out, because if it was only beta, your radiations would have stopped here. Nothing should be detected on the other side. Okay. 36th. The reading on the detector placed near a source is 536 counts per second. This is my original count, of which background radiation is 44. Okay, which means count only due to sample is 536 minus 44. The half-life is 34 hours. How much is the reading after 68 hours? So 34 is one half-life, 68 is two half-lives. I'll need my calculator, just a minute. So 536 minus 44, 536 minus 44. This is my original count only due to the sample, which is 492. This I divide by 2. This is my 1 half-life. I divide by 2 again, which means after 2 half-lives, my count due to the sample becomes 123. So a lot of students will mark 123, but no. They're telling you how much is the detector detecting the count. So remember, detector is also detecting background radiation. We clear? So your final answer has to be 167. Are we clear with this? The detector is not only going to detect the sample count, it is also going to detect the background radiation count. Now, 37th one. A planet in the solar system is at a point in its orbit where it is closest to the sun. Which row is correct? It is closest to the sun, which means it should have the highest kinetic energy, and therefore its orbital speed is maximum. Okay, also the total energy remains constant, and total energy is Ke plus Pe, very similar to pendulum. So if its kinetic energy is maximum, its GP has to be minimum. Again, this is mentioned in your syllabus. That's why I tell you all to read the syllabus. 38th. What is the main process that powers the sun? Main process that powers the sun, it's fusion. Are we clear? And fusion is where you have hydrogen, deuterium, tritium turning or combining to form helium. Not turning, sorry. Combining to form helium. So the answer is C. Remember, a star dies when this hydrogen count decreases. Okay, that is why it collapses under its own gravity, because now the outward force has reduced. 39th. This is my distance given. At what speed is the galaxy moving away? This is your Hubble's law question. You know V is equal to h naught d. This is the only value that Cambridge tells you to remember, which is 2.2 into 10 raised to minus 18 into my d is 3 into 10 raised to 20. Okay, so this becomes 6.6 into 10 raised to 2, which is 660. So the answer is 660. Two options with 660. What unit have they given? Kilometer. I have also used kilometer. So kilometer. Okay, very smart. So the answer has to be A. And the last one. An astronomer observes a distant galaxy. The table shows how the distance and the speed of the recession, which means the speed by which it is going away, is determined. Which statement is correct? Okay. Now, the distance between the object and us is determined by using standard candles. And supernova is a type of standard candle, which means A and B could be the possible answer. And speed of recession, the velocity by which it is going away, is determined by redshift. So the answer is A. Brightness of the galaxy and brightness. Okay, so this is wrong. It will not give us the speed of recession. And therefore the answer has to be A. Okay. Any more question? Nope, done. 40 questions done. Yeah, 40 questions done. Okay, bachas. So do let me know in the comment section which paper you want me to solve or which concept video should I make. Until then, take care. Adios.